All right, it's our last factoring lesson, at least for a while, and today we're going to learn how to factor by grouping. So when you're trying to factor a polynomial, and this time it has 4 terms, we might have to look at some things a little bit differently. You can sometimes use the distributive property to factor by grouping. I want you to notice something. If I was multiplying y squared plus 4, I'll write that down here again, times y plus 3, I want you to notice that we would multiply y squared by y and y squared by 3. So really, we've just multiplied y squared by y plus 3. And then we'd take 4 and we'd multiply it by y, and we'd take 4 and we'd multiply it by 3. So we'd take 4 and we'd multiply it by y plus 3. So what I want you to think of is we can do this in reverse. If you kind of notice, both of these have a y plus 3 in it. Okay, so y plus 3 is one of my factor pairs. Okay, and y squared got multiplied by both of that, and so did a positive 4. And so if we worked backwards from this, we could see that it equals the same thing as the factored form, y squared plus 4 times y plus 3. Okay, so when we factor by grouping, we look and we first of all, we want 2 terms in parentheses to be the exact same thing, because that means when I'm doing the grouping, they would have both gotten distributed by the same thing. So n minus 2, they got multiplied by 3n squared and by plus 5. Okay, so if I was trying to factor that out, 3n squared times the quantity n minus 2, so this would have gotten multiplied by that whole thing. And then plus 5 would have gotten multiplied by that whole thing. So it looks like that worked out. So if you have a set that is in common, that can be one of your 2 binomials. And we're going to pull out the other leading terms into our other binomial. Okay, so here's where that's an example, and it's going to get a little bit more complicated. So when I'm trying to factor something like this, so here's a polynomial, it has 4 terms in it, but I don't see anything neatly broken up for me. So what I'm going to do is something that's called factoring by grouping. I am going to only look at 2 terms at a time. So I'm going to look at that first pair, and I'm going to look at the second pair. And what I want to do is find the GCF separately of each term and just factor out the GCF by itself. So if I look at 6x cubed and 3x squared, it looks like 3x squared is my GCF. And if I work backwards, 3x squared had to be multiplied by 2x to get that first term, and 3x squared just had to be multiplied by 1 to get the second term. Okay? If I look at the next one, negative 4x minus 2, I'd say my GCF is negative 2. Negative 2 times 2x gives me negative 4x, and negative 2 times 1 gives me negative 2. So this is looking similar to what I just did. You're going to notice that I have a 2x plus 1 here, and I have a 2x plus 1 here. If I don't have terms that are the same, this technique's not going to help me out. But since they match, that's going to be one of the terms of my binomial. In the first term, it should be like these leading coefficients, 3x squared minus 2. Okay, because this is tricky, I want you to get in the habit of seeing if it works and if it checks out. So I'm going to go ahead and multiply this out using the distributive property. So 3x squared times 2x is 6x cubed. 3x squared times 1 is 3x squared. Negative 2 times 2x is negative 4x. And negative 2 times 1 is negative 2. Lo and behold, that gets what I had before. So it checked out, but my final answer is this one, 3x squared minus 2 times 2x plus 1. Okay, I would like you to try this on your own if you can. I'm going to rewrite it. So I've got 8t to the 4th plus 12t cubed. I'm going to use a different color because I'm going to group these differently, plus 16t squared plus 24t. All right, so I'm going to look at my blue terms first, and I'm going to find the GCF and factor it out. So 8t to the 4th and 12t cubed, it looks like 4t to the 3rd goes into both of those. Okay, to get from 4t to the 3rd to 8t to the 4th, that's multiplied by 2t. To get from 4t cubed to 12t cubed, that's plus 3, multiplied by positive 3. Okay, for my next one, it looks like 8t goes into that. Okay, and when I do this, 8t times 2t is 16t squared. And 8t times 3 is 24t. Okay, again, this looks really convenient because I have 2t plus 3 here and 2t plus 3 here. So it looks like 2t plus 3 is one of my factors. My other factor should be 4t cubed plus 8t. But alert, 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 I'm almost done, but do you notice that this term is not completely factored because there's a GCF that goes into both of those? So 4t happens to go into both of those, so I'm going to actually say 4t times t squared plus 2 times 2t plus 3. So now I took this 4t cubed plus 8t and I factored that to 4t times t squared plus 2, and then I left 2t plus 3 alone. That's my final factored form. Okay, so when we have 4 terms, I like this strategy, but a lot of people actually factor trinomials by grouping like this. I will admit that I actually never use this strategy except for when I teach it. However, I have found that a lot of kids actually tend to like it. And at State High, a lot of the teachers use it a lot. So it's just not a personal preference of mine, but I'm going to teach you it and see what you think. So factoring trinomials by grouping. So I only do this if you're having a lot of trouble factoring an ax squared plus bx plus c trinomial. Then you can try this method. So the first thing that you want to do is find the product AC. So you're going to take A times C and multiply them together. At State High, a lot of times they call this the rainbow method because they're drawing that little rainbow over the top. Then you're going to find the two factors of AC that have a sum of B, so they add up to B. Then you're going to rewrite the trinomial using that sum, and then finally factor it by grouping. So I will show you how this works. But you're going to always want to get out the GCF first so you don't have a lot of other annoying things to deal with. Okay, so right here we're going to factor 24h squared plus 10h minus 6. This does have a GCF. 2 goes into all of that. So I have 2 times 12h squared plus 5h minus 3. So what I'm looking for here, I'm looking for a product AC. So I'm going to multiply 12 times negative 3. There I get negative 36. And what I'm trying to do is find two numbers that multiply to give me negative 36. And I want them to add up to 5. So they should multiply to negative 36 and add up to 5. If I think of those, I know 9 plus negative 4 adds up to 5. Okay, so what I'm going to do is I'm going to use these terms in my B part of my polynomial or my trinomial. So 12h squared, I leave that the same. But instead of writing 5h, I would write 9h minus 4h. So I've used this 9 and this negative 4 to make 5. Okay, and hopefully you see that 9h minus 4h really is 5h. And then we just leave c alone, minus 3. Okay, and we still have this 2 out. I'm going to deal with that later. Okay, so now I'm going to factor this by grouping. Okay, and so in 12h squared plus 9h, we're going to have factor out, it looks like 3h is my GCF. And then that's going to be times 4h plus 3. And the next one, it looks like negative 1 is my GCF. That's going to be times 4h plus 3. So then I know in this case it looks like my factors are 3h minus 1 times 4h plus 3. And I already have my GCF of 2. So I'm going to pull it down, and that would be my final factored answer, my final factored form. So I'll show you one more example like that just to get you exposed to it, and I want you to try it if you can. Like I said, I do use factoring by grouping if there's 4 terms. When there's 3 terms, I really have never used it except for when I've taught it. So this one, factor 63d squared plus 44d plus 5. So this time it does not look like I have a GCF. So what I'm trying to figure out is two numbers that have a product of 63 times 5. Okay, so I want them to multiply to equal 315. And I want them to sum to my B term, which is 44. Okay, so because I think this is kind of a lot of guess and checking, because you have big numbers that you're working with already. But some people are not bothered by that. You're going to have to play around with things that multiply to give you 315. Okay, and I don't think these are really easy. So, I mean, you might want to actually list the factor pairs if you like that 1 times 315 and just keep going. But I eventually find that 9 times 35, that does, well, I mean, I could have done 3 here. 3 times 105. 9 times 35. 9 and 35 add up to 44. They sum to it. So those are the pair I'm going to use. And when I factor this, I'm going to say 63d squared plus 9d plus 35d plus 5. So you can see this still equals the same thing as the one above it, but I have 9d and 35d add up to 44d. Okay, so now I'm going to factor by grouping. So I'm going to grab my first two terms. And by the way, it's totally okay if you made that 35d plus 90. It should still work out. So I'm going to find the GCF of each term. So it looks like here 9d actually goes into both. That's times 7d plus 1. And then here it looks like 5 goes into both. And that's also times 7d plus 1. So it looks like when I factor this, I get the quantity 9d plus 5 times the quantity 7d plus 1. And if I checked that, I'm going to go ahead and do that. That's 63d squared plus 9d plus 35d plus 5. And lo and behold, that's 63d squared plus 44d plus 5. So it looks like I checked out just like I wanted to. Okay. The last one, word problem. A rectangular prism has a volume of 36x cubed plus 51x squared plus 18x. I want you to factor it to find some possible expressions for the length, width, and height of a prism. So you're going to need to remember that volume equals length times width times height. So what we're looking for is 3 possible polynomials or a set of some sort of expressions that multiply together to give us this, 36x cubed plus 51x squared plus 18x. So the first thing I think would make this easier is pulling out a GCF. Okay, so if I'm looking here, it looks like 3x goes into everything. So this is going to be 3x times the quantity 12x squared plus 17x plus 6. Okay. And then you are going to have a choice of how you want to try to factor this, because right now, if these were my 2 dimensions, I would not have a full box, so I need a 3rd dimension. I need to factor out 12x squared plus 17x plus 6. So you pick what you like, what strategy you like, whether it's factoring by grouping or still using the cross product. I'm going to try to do factoring by grouping just because that is what we're focusing on today. So the first thing I'm going to do is 12 times 6 equals 72. And what I want to do is to find 2 factors that multiply to 72 that add up to 17. So I know that 8 and 9 do. 8 times 9 is 17, but 8 times 9 is 72, but 8 plus 9 is 17. So I'm going to rewrite this as 12x squared plus 8x plus 9x plus 6. And then I'm going to try to find some GCFs and pull it out. So looking at these terms, I've got 4x as my GCF, and that's going to be times 3x plus 2. And then here, it looks like 3 is my GCF, and that's also times 3x plus 2, which is a good sign. So those match. So it looks like that part in there is 4x plus 3 times 3x plus 2, and I still have this GCF out at the front, 3x. So now you should notice that I have 1, 2, 3 terms that are being multiplied together. So those could be my length, width, and height. I don't know which one's what, but it's possible that this is a 3x by 4x plus 3 by 3x plus 2 box. Okay, it's possible. There's more than one option. But okay, so that's factoring by grouping in a nutshell. It's a little bit to chew on and practice, and I will see you later.